Bismillahirrahmanirrahim. Welcome to my YouTube channel Calculus and Mathematics Learning. In the previous videos, I solved exercise number 4.1 related with chapter number 4, Differentiation of Vector Function FSC Part 2 Mathematics, Class 12 Mathematics. In today's video, I am going to solve and started with new exercise number 4.2 related with the same chapter number 4, Differentiation of a Vector Function. So the first question of exercise number 4.2 is related with the differentiation of a vector function for the first time derivative. So let's move toward question number 1 of exercise 4.2 class 12 math. Differentiation of vector function is the name of the chapter number 4. Question number 1 tells that find the vector derivative f prime of t of the following vector functions. F prime of t means that we will differentiate the given vector function for the first time. So if they tell that find the derivative directly, so for the direct method we will use generalized power rule of differentiation. So derivative of t with respect to t will be 1, so 1 multiply I gives us I. Derivative of t square according to the generalized power rule, 2 it is the power, so it will come to the front and we will subtract 1 in the power, so 2 minus 1 gives us 2t, so it becomes 2tj. And over here the derivative of t will be 1 and derivative of t cube according to the generalized power rule, power will come to the front and we will subtract 1 in the power, it becomes 2, so it becomes 3t square k. This is actually the general derivative by direct method. Now if they tell that find the derivative using first principle rule or find the derivative using by definition method, so we will use the f of t plus del t minus f of t divided by del t. This formula is called first principle rule. So first we will replace the given function t with respect to t plus del t. So replace t with t plus del t, it become t plus del t I, it become t plus del t whole square j, and it become t replaced with t plus del t, and over here t replaced with t plus del t, it become t plus del t whole cube into k. Now by simplification it become t plus del t I, it become t square plus del t square plus 2 del t, we use a plus b whole square formula, and t plus del t will come down as it is t plus t whole cube, it is actually equal to a plus b whole cube, which is equal to a cube plus b cube plus 3 times of a square into b plus 3 into a into b square. And after this we will subtract f of t, so we over here we will bring minus sign, so it become minus ti and minus t minus t square j, and it become minus into t plus t cube into k. Now after simplification it become t plus del t I, this is actually t plus del t I, so we will subtract minus t, so it become t plus del t minus t into I plus t square plus del t square plus 2 del t will come down as it is, and we will subtract the coefficient of j, which is actually negative t square inside, and t plus del t plus t cube plus del t cube plus 3t square del t plus 3t del t square will come down as it is the coefficient of k, and over here the coefficient of k is minus t cube, so it become minus t into minus t cube. Now after this t cancel out with t negative, we left with del t I, it become del t square plus 2 del t and minus t square. Minus t square cancel out with t square, we left with del t square plus 2t del t, and over here t cancel out with negative t cube cancel out with negative t cube, we left with del t plus del t cube plus 3t square del t plus 3t del t square. Now according to the formula we will divide with del t, so divide each and every term with del t, so del t cancel out with del t, we left with I, and del t square cancel out del t, we left with del t cancel out with del t, we left with 2t, and del t cancel out with del t, we left with 1, del t cube by del t gives us del t square, del t cancel out with del t, we left with 3t square, del t square cancel out with del t, we left with 3t del t. Now in the formula we have limit del t approaches to 0, so put del t 0 gives us 0, it gives us 0 and it gives us 0, we left with I plus 2tj and 1 plus 3t square k. So this is actually the derivative using by definition method. Over here by general method it gives us I, according to the first time derivative by principal method it gives us I plus 2tj plus 1 plus 3t square k. It means that both the method gives us the required correct and exact answer. This is actually the first time derivative. Now move to the next part of part number B of the same question number 1. It tells that a function is given f of s is equal to si plus s square j plus s square k plus 2s square I minus sj plus 3k. So according to the formula we will replace this s with s plus del x, so it become s into s plus del s I, it become s plus del s whole square into j, it become s plus del s whole square into k, it become 2 into replace s with s plus del s, it become s plus del s whole square I, and it become minus into s replaced with s plus del s into j, and plus 3k will come down as it is. Now by simplification it become s plus del s I, it become s square plus del s square plus 2s del s according to a plus b whole square formula, and using the same formula over here it become s square plus del s square plus 2s del s k. After this it become s square, so multiply s square with 2, it become 2s square, it become del s square multiply with 2, it become del s square, it become 2s del s multiply with 2, it gives us 4s del s. Using the same formula and multiply that formula with 2, it gives us 2s square plus 2 del s square plus 4s del s into I. After this it become minus into s plus del s j and plus 3k, this will come out as it is. Now by simplification it becomes s plus del s and add with 2s square plus 2 del s square plus 4s and del s into I. Now the j coefficient is s square plus del s square plus 2s del s and add the j coefficient which is minus s and minus del s. After this the k coefficient is s square plus del s square plus 2s del s and over here the coefficient of k is 3, so add 3 over here. Now after this minus f of s from f of s plus del s. F of s is actually si, so minus into si plus sj plus s square k and minus time of 2s square I minus sj plus 3k. Now by simplification it will give us del s plus 2 del s square plus 4s del s I plus del s square plus 2s del s minus del s j plus del s square plus 2s del s k. Now according to the formula we will divide with del s. So divide this term with del s, this term with del s and this term with del s. So del s cancels out with del s, we left with 1. Del s square by del s gives us 2 del s and del s cancels out with del s, we left with 4s. And del s square divided by del s gives us del s, 2 del s cancel out with each other, we left with 2s. Del s cancel out with del s, we left with negative 1. Del s divided by del s square by del s gives us del s, 2s del s by del s, so del s cancel out with del s, we left with 2s. Now according to the formula over here del s approaches to 0, so it becomes 0, it becomes 0, it becomes 0. We left with 1 plus 4si and 2s minus 1 into j and plus 2sk. This is actually the first time derivative using first principle rule. We can also find the derivative using direct method. Derivative of s is 1 and plus our derivative of 2s square, it gives us 4s, and the coefficient over here is I and over here is I, so we will write it 1 plus 4si. Derivative of s square is 2si, 2s, and over here derivative of s is negative 1, so it becomes 2s minus 1j, and plus derivative of s square is 2s and derivative of 3k is a constant derivative is 0, so it becomes 2sk. So 1 plus 4si plus 2s minus 1j plus 2sk, these are matched with each other. It means that this is the derivative using first principle rule for the part number B. Now move to the last part of today's lecture, part number C of question number 1. A function is given f of theta is equal to cos of theta I plus tangent theta j and plus 3k. So what will be the derivative for the first time? So it will be represented through f prime of theta. Remember that derivative of cos of theta is always equal to negative sin theta, and I will come down as it is. Plus also remember that derivative of tangent theta is always equal to secant square theta and j. And over here 3 is a constant, so remember that derivative of any constant is always equal to 0, so its term will give us 0k. So the required derivative of this function, vector function, will be minus sin theta I and plus secant square theta j. So this is actually the required derivative for this function. You can also try this function through the first principle rule and through the definition method. So with this question I finish my lecture. In the next video I will solve question number 2 of this exercise for the second time derivative of the vector function. So thank you for watching, subscribe my channel and also hit the bell icon to receive the upcoming notification about second year mathematics. Thank you.